So students, there is some issue with the previous link. So I'll just share the Zoom link on the chat once again. I request please share the links if like if your friends are facing a issue to join the session. So I request please inform your friends to join this link. Okay, I'll be sharing the Zoom link on our chat. In LMS, it has been got updated. If they are joining from LMS, there will be no issues. So as we can see, there are only 20 participate and the people are joining. So we will wait for 5 more minutes, like 4 more minutes. At 7:10 we will start. Okay, I request you all, please inform your friends uh, to join this link. Good evening, all. Shahid sir, good evening.
Good evening, ma'am.
Yeah, you can start the session, sir.
Okay, ma'am. Okay, thank you. So let me share my screen. And please confirm that my screen is visible.
Yes, sir, it is visible.
Okay, thank you, ma'am. So in the previous classes, we have studied about machine learning. In first session, we have gone through what is machine learning and what different types of the machine learning approaches are. Okay, and in the last one, that is 10th day of this session, that we have covered different types of the exploratory data analysis and feature engineering. So now we are going to learn about supervised learning, and so today we have to focus on the supervised learning, and we will focus mainly on the linear regression, and we will implement with Python, and we are going to use today scikit-learn. For that you have to install or import if you are using in Google Colab. Okay, so you just import. If you are going to use in Jupyter Notebook, so you have to install sklearn. So for this, before going to this implementation in Python, let's first understand what is supervised learning and what is different types of the supervised learning, and we are going to work in this one, linear regression. Okay, so let's first understand what is supervised learning. So when we talk about machine learning, so we have seen that first is supervised learning, and another is something like unsupervised learning. And we also have seen that reinforcement learning. Okay, so today we are going to talk about supervised learning, and we will focus. Let's first understand about the definition, and theoretically we are trying to find out. We are trying to understand what is supervised learning, and what different algorithms will fall under this supervised learning. Okay, so let's say that we have a data set. We have data set of the sales and advertisement cost. So we have two columns only in this. We have two features only. And let's say that something our this data set looks like. Let's say that 30,000, and yeah, let's say here I am going to put here in K. Okay, so I'm not going to write here. Just to understand, 30,000 advertisement, if I am going to spend, what will be the sale? So I'm going to record all the advertisement cost and the sales in my data set. So let's say that I have spent 30,000, and my sale is, let's say, 100,000. Okay, this is also in thousand. Okay, this way I'm going to record all the data. Let's say 40,000, 30, 35,000, all these things, whatever the data I am going to record. 35, maybe how many thousand records are more than that we can have. Okay, respective, I am going to record also these things, the sales. Let's say 200,000, 250,000, all these things. Okay, so in this case, what we are going to do, we are going to find out some relationship between the variables or the features. So let's first understand just with this data set that what are the features. Okay, because we have to know that what are the features, and what are the input features, and what will be the our output feature, or we are going to say it as target variable, and also we are going to say it as labels. Okay, and for the input features, we are going to understand that uh, input features. Okay, so in feature variables or input feature we are going to talk about. Okay, so one thing, that one feature will be in our data set if we are going to talk about supervised learning. So that will be our labels, or we are going to say target or output. Okay, so if in our data set we have output feature, are the labels. So we are going to perform a supervised machine learning algorithm. We are going to train a supervised machine learning algorithm, such type of the data. Another example you can find. Okay, you have, let's say, height and weight. Okay, so in this will be our label, and this will be our input feature. Okay, so on the basis of height, we are going to predict weights or something like that. Okay, so what is that in these cases? Whatever you have, the sales or the feature, this value, the sale is dependent on this. As advertisement cost is increasing or decreasing, in the same way it will behave, like sales will increase if our advertisement cost is increasing. And we have to find out the relation. If height is increasing, then weight is increasing or not. So we are going to find out relation. So one variable you are going to find out will be dependent on the another one. So this will be dependent. This is dependent. Weight is dependent on. This is basically dependent on height. Okay. So if this type of the data you have, that one variable, one feature, or the one label is dependent on the other features, other variables. Okay, so we are going to perform a supervised machine learning. There are different types of the data set. There are different examples of the data set you can have. Okay, but in that supervised learning, you have output feature and the input features. So output feature, generally we have only one output feature, and you may have different input features. Not only one input feature, but you may have different input features. Okay, so generally we are going to represent the output feature or the labels by y and x by, and the input feature by x. Okay, and the input feature may have like x1, x2, x3, or x4. Okay, different input features. You may have different input feature, and you will have one input, one output feature, that will be your label or your target variable. Okay, so in our case, the weight is dependent on height, and in this case sales is dependent on the advertisement cost. Okay, and there are different examples of this machine learning, supervised machine learning data set you can have. Okay, so may have, if input features are more than one input features, so you are going to perform different types of the algorithm you are going to take. If you have only single input feature, you are going to perform some different types. Okay, so when we talk about this, so if our data set has output features or the target variables, we are going to perform supervised learning. But in supervised learning, we again can perform two different types of the task. So in supervised learning, we can perform either regression or the classification. Okay, and again, this will depend on whether you are going to perform a regression task or you are going to perform a classification task. It will depend. It will depend on your this target variable or the label, or you are going to say this y. Okay, so you have to focus. Here we have weights. Okay, here we have weights. Let's say 35 kg, 35.5 kg, and 38 kg, 38.25 kg, different. So if your target variable are the labels, your label is continuous data, like this, weight or the sales or the salary, different examples we have. Okay, so numeric values and that numeric value is basically continuous numeric values. If this type of the labels you have, you are going to perform a regression task. Okay, because what? On the basis of these input features, you are going to predict the value of the sales. Okay, so before that, before going to prediction, we have to find some relationship between this x and y, are the input features and the output features, that is target variable. Now, if you are going for the classification, so you have to look into that which type of the data your target variable or the data you have. Okay, so in this case, your label will be categorical type. Your label will be categorical, or even not only categorical, you can have discrete values. Discrete values. Okay, either zero. Discrete means what? Discrete basically 0, 1, 2, 3, 4, 5. Okay, these type of the numbers, exact a whole number you will have. Categorical features or categorical variables you will find. Okay, let's say cat image or dog image. Okay, so you will have some text classification, you have some classes, you will have some categories. Okay, you are going to divide your whole data into cat or dog. Okay, or you are going to divide your data into let's say diabetic data, diabetic patient or not diabetic. Okay, so your target feature, if your target feature or the target variable, that is label, contains like this, let's say this is dog, cat, and all the x features. Okay, x features, you will have different values. Okay, so this value, this value, this value, whatever the numeric value you have here, numeric values, and maybe categorical may also you have, but let's say all are numerics, and your label is your like dog, cat, dog, dog. Okay, so all these type of the data, it will depend on your labels. Okay, so which type of the label is basically you are classifying your whole data into two parts. Okay, like dog or cat. Okay, so in this case, this if you have this type of the data, and in that data set the label is basically categorical. Okay, so you have categories, either your data belongs diabetic or not diabetic. Okay, so this type, you have two classes or two groups of your data. Okay, so you are going to classify your whole data into two groups. So you can perform this type of the data in the classification. Okay, so you have to keep into mind which type of your data set you have, and on the basis of those data you are going to select which type of the algorithm. So if your data is continuous numeric, so you are going to perform a regression. Okay, so there are different types of the regression algorithms. Okay, so you can find regression algorithm like you may have simple linear regression. Okay, simple linear regression and multiple linear regression. Okay, so linear regression basically, this linear regression, you are going to divide into two different categories, two different types of the linear regression. Okay, so linear regression is the simplest one that you can, that will fall under the regression type of the class, regression types of the machine learning task. Okay, so in today's session we are going to learn about linear regression, and we will go somehow some little bit theory, and we will find that what is actually linear regression is, and we will implement in Python. Okay, so for that thing, if you are using Jupyter notebook, so you have to install your scikit-learn, because we are going to use scikit-learn, so you can install sklearn. Okay, so these two, not two, these they are same. Okay, sklearn and scikit-learn are same, so you can install using pip install sklearn, but actually this is generally known as, this sklearn is known as scikit-learn. Okay, so when installing, you are going to install pip install sklearn. Okay, I will show all these things. So let's understand little bit little bit theory, and we will move to the implementation. If you have any doubt up to this, so please let me know, and we can talk about. If you have any doubt, you can put in the chat, okay? And I will look into that. And yeah. So before going to this, I have this one. Okay, I have shared all the data set and the Jupyter notebook in this. What is that? This is the repository. Okay, and within that, the last one, that is 10th day of the sessions. So ED and data preprocessing feature engineering, we have already uploaded all these things. And for today's session, I have uploaded the files. Okay, so you will find different CSV file. This is CSV car CSV file. This is newspaper data CSV file, and this is newspaper IPYFNB notebook. Okay, that will take this newspaper data. Okay, so I will share this uh, link. Okay, and you try to when we'll start coding. Okay, so you try to in like before coding, you try to these, at least these two. Okay, newspaper data and newspaper dot IPYNB, these two files you just download, and we are going to work today on these two files. Okay, so this will be your Jupyter notebook and this will be your CSV data. So you can download all the things. Okay, you can download all the things, no issue. Okay, but today we are going to work on simple linear regression. That is that it will take only one input feature, and that is, and for the multiple linear regression it will take multiple features. Okay, so if you want, you can download all of these things. Okay, but today we are going to work on newspaper data and these things on newspaper data. If you work, and I will try to make you understood that how a simple linear regression works. Okay, so here I'm sharing the link of the this repository. Okay, so you can download files, and before that, let's understand little bit theory, so that you will be able to correlate. You'll be able to relate that whatever we are doing in practical, that will how it will work. Okay, so this is the learning goal, that what is regression, why we are going to do regression, what will be the scatter plot, some correlation coefficient, okay, associations, and the simple linear regression. Finally, we are going to do this one. Okay, so basically, let's say that here we have taken this example that was basically height and weight are this one. Okay, so let's take another example and make understand that what is how linear regression will work basically. So let's say that what is years of experience. Okay, this is very common example, years of experience, and that what will be the expected salary. Okay, this is another example, that this salary, this is basically your y, and this salary depends, this output feature depends on what? The experience. But not only experience, there are many other features that will affect the salary. Okay, what is the highest qualification? Okay, what different types of the input feature you will take. Okay, but for now I'm taking just this as a simple, to make it simple linear regression as simple. I'm going to take only one input feature. So okay, here it is what input feature, and here my y is what my target are the label. Okay, so this will be target, means we are going to predict this value, this variable on the basis of x. Okay, so this will be what, this will be dependent also, this will be dependent variable, and this will be your independent. Okay, I hope this is clear, because this why this salary is dependent on the years of experience. As many experience you will have, your salary will increase. This is obvious and this is correlated. Okay, so these two variables are correlated. Okay, so what we are going to find, just I am not going to give you the exact values, but how this correlation will work or the linear regression will work. Okay, so on the basis of the data, we have somewhere this one. Okay, here. Let's try to understand this. We have uh, okay, experience, that is, let's say 2 years of experience, 50,000, 4 years of experience, 70,000, 3 years of experience. This is just the data. Okay, and now you are going to find out the relationship. So main aim of the linear regression, main aim of the linear regression is to find out relationship between two variables or more than variables. Okay. So here we have salary. I'm going to find out a relationship. So if we talk about regression, okay. So we are going to find a relation between X and Y. Okay. So if you have any doubt, okay, please put in the chat. Okay, I will read and I will try to explain what is your doubt. Okay. So when we establish a relation, that we have established a relation between X, that is Y and X. So I'm going to, let's say that relation, how I can represent the relation. Okay. So let's move to this one. This is very important that to understand. So we have our data and we are going to find out a relationship. We are going to find out a, so how can I find the relation? Okay. So when we are talking about linear regression or the regression, generally a simple linear regression, so we are going to find out a line, okay, a straight line basically. So we are going to find out a line and that line will give, okay. So if let's say in mathematics you have gone through, if you have a line y equal to mx plus c, okay, and these m and c is already known, okay. So these are known and let's say that value are something like that, y is equal to x plus 5, okay. So on the basis of these values, this line, using this line, can you will be able will you be able to find out the value of x, value of y? Can you find the value of y when x is given? Okay. Okay, so this type of the relation. So let's say that x is 100. Okay, so you will be able to find out the value of y. So on the basis of here, you see, this is x and this is y. Okay, so if x is given, I'm going to find out a relation between these two such that for the next, let's say that here we don't have any value, that is 8.8. Okay, 8 is not given. Okay, so 8 is not given. So I'm going to use these data set, these data points to find out a relation like this. And I'm going to predict for the 8 years of experience. So what will be the 8 years of experience salary? A person who has 8 years of experience, so what will be the salary? So this type of the linear regression, if I am going to establish a relation, so using this straight line relationship, I can predict for the new values of this experience or the new values for this X or the input feature. Okay. So main aim is what? Our main aim is to establish a relationship between these two variables, and that relationship, how you can establish, using this straight line. Okay. So for this thing, just to visualize what you can do, you can plot a scatter plot. This is basically a scatter plot. Okay, if you haven't gone through the scatter plot, okay, so you can visualize a scatter plot. We will also visualize in the okay, when we are going to implement, you will visualize using scatter plot, and you can use matplotlib. Okay, for the scatter plot. Okay, there are different other library like Cborn is there, and other libraries are there Python that can be used to visualize as a scatter plot. Okay, now this is what this is data distribution, that how data distributed. Here this is at x-axis we are going to take as the experience. Okay, this is the experience like 0 year, 2 year, 4 year, and these things. And what we are going to do, and basically this will be your salary. Okay, so this y-axis is basically salary, and here your x-axis is what? Experience. So now I am going to find out a line that will pass most of the line, that will pass through most of the line. There is a little bit more complicated things inside this, but try to understand. I'm going to find a straight line that will represent most of the line. Okay, if it is not, you can do like this. Okay, this may be the best fit line, or this may be the best fit line. Okay, so let's say that you find a best fit line, and this best fit line basically, let me take another. Okay, so you are going to find out, if you can find a straight line, then for that straight line you need two things, these two things. You need the slope of that straight line and the intercept. So intercept is here. Okay, so from 0 to where this intercept is, this will be your c value. Okay, and what is slope means how inclined it is. Okay, so you can find the slope for anything like that. This way you can find, sorry, you can find any 2 points here and any 2 points here, and you can just find this value and this value. Okay, and just you are going to divide this value by this value. This will be what? Whatever the y changes. Okay, salary changes in salary, if the your experience is changing from here to here. So what will be your m? So this will be delta, the change in y-axis. Okay, and change in x-axis, and m you will get by dividing these two. Okay, so you got this one m, and you got c. Okay, now you will have what? You will have your this one, your line, something like that, mx plus c. Okay, you will get this thing. Now you can use this line to predict for the new value. Okay, this is just for the mathematical way, that how I'm going to find out. So here this y represents salary. So you can say you are going to predict salary if you have this slope. Okay, slope or the gradient, and you are going to multiply with that. X is what? Experience. Okay, so for any particular point of the data, let it 8 year of the experience, how much my salary will be. Okay, so you can find m and c, you can find using this straight line. So my main aim is what? My main goal is what? To find m and c here. Okay, so let's generalize the straight line. You have to find out what? You have to find out slope and intercept. This will be the gradient or the slope or the gradient. Okay, so this gradient m is nothing but gradient. Okay, you will deal many times gradient or the slope, and this will be your intercept with y-axis. Okay, so this is y, where your this line is going to intersect. Okay, now let's talk about this thing with your machine learning term. Okay, so this line, if this line is your best fit line, okay, this is your going to best fit. I will talk about how a best fit line you can find. Okay, so this line will be your model. Okay, exactly this y equals something, whatever you have written, this line mx plus c is going to be your model, and that using that model you are going to predict any value. Okay, so I hope this is clear, because what? You have x and y, two variables, you have experience and salary. Now you are going to find a relationship between these two features. Okay, now you find the salary. You find the relationship. Relationship is represented using a straight line. Okay, and a straight line is mathematically you can do something like that. Y equal mx plus c. Okay, when you got this thing, now you can use this model or this straight line to predict for the new one. Okay, I hope this is clear. So now let's move to the main thing, that what is basically linear regression or the linear. So we are going to find out basically. Okay, so here let's try to understand, and let me make it more or okay presentation like this. So we found that what it is basically. So let's say like this. We said that you can find some relationship like mx plus c. You can find a straight line. Either you can write c equal mx, y equals c plus mx. Okay. When we are talking about machine learning, we are going to represent a proper way. Okay, so we are going to use these beta naught and beta 1. Okay, so this beta naught is nothing but this is your intercept, and this beta 1 is nothing but your gradient. Okay, so don't confuse with this notation. The simple, it's very simple. Okay, here it says that you can find a relationship between weight, height, and weight. Okay, so you can represent like this. You can find a relationship between weight and height, something like that. So if you are going with beta naught and this one, so you can say beta naught plus beta 1, and you are going to multiply with height. Okay, this thing. This is your expected weight when even we have some height. Okay, so for any height you are going to predict the weight. But what is that? First you have to find out these two, beta naught and beta naught, these two unknown things. Okay, so these two unknown things we are going to call them as parameter. Okay, we are going little bit in machine learning. These are the parameters. Okay, now our main goal is what? To find the optimal value of these parameters. Okay, so what we will do, let's say, then this is also things. Okay, so what we are going to do to find out these two values, how you are going to find, you are going to train the this algorithm on the data. Okay, so whatever the data we have data for the salary and experience, the data we have height and weight, we are going to train our model. So we will look at how training will work. Okay, so that is the main thing that we try to understand. Okay, so there are different things, like here used car, you can find out the relationship between car cost. This will be for the used car cost. Okay, so this is nothing but beta naught or beta 1. If you're taking, you will take beta 1. Okay, and this is one other feature, that is input feature basically, that is miles driven, how many miles or kilometer it is driven. Okay, and don't confuse here, we will introduce what is error. Okay, so this will be your line. Okay, this will be your model that you are going to use basically. And using this model, if you have beta naught and beta 1 values, you are going to predict the car cost on the basis of how many miles or how many kilometers. If it is in kilometer, in India we are using kilometers basically. Okay, so how many kilometers the car already has driven. Okay, so in this way, this type of there are many examples that you can find in real life. Okay, so let's move ahead and do basically this thing. So this, for the experience and salary, you got this straight line, and we are going to represent. So this is okay. Basically, we are not taking this one. Okay, yeah. So let me describe a little bit more about this. Okay, so on this data set we are going to work. Basically, on this data set we are going to work today. Okay, so we have daily circulation of newspaper. Okay, this is another example. Okay, so in real life you can find a lot of examples. Okay, so you have to go through and you have to check that which type of the labels, which type of the target features we have. Okay, so if you go here, okay, and you can find here, this is newspaper. What is the name of the newspaper? Daily circulation and Sunday circulation. What is the name of newspaper? What is daily circulation? What is Sunday circulation? Okay, so you can find here, this is basically what your label or the target. Okay, this is your label or the target. Let's say target. Okay, this is your target, and these two are input feature. Okay, yeah, these two are input feature. Okay, but when we are going into regression, okay, when we are going to regression, we need numeric features. Okay, we need numeric feature. This label should also be numeric, and this daily or the input features would also be numeric. Okay, so let's focus on only these two, only. Thus we have daily circulation and we have Sunday circulations. Okay, so you can find this Sunday circulation or your target value is how this is your continuous. Okay, if it is continuous, you are going to perform the regression task. Okay, so yes, we are performing regression task, we're trying to understand, and this is continuous. Okay, so whatever daily circulation you have, okay, and you can predict for any other daily circulations. Let's say that almost 1100 we have on these things. Okay, let's say that 1200 you don't have any daily circulation, that is 1200. Okay, so now if you got a relationship, you got a regression line, that will be something like that. Okay, so you will find Sunday circulation and this will be your daily circulation. Okay, so you have daily circulation, just multiply whatever the daily circulation you have with these two unknown features you have to find. Basically, first, before you have to calculate this thing. So we'll implement and we'll try to find out how this will look. Okay, so what will be the beta naught and what will be this one, these two, and how you are going to find out the Sunday circulation on the basis of daily circulations. Okay, so for any unknown value, let's say that in this our data set 1200 daily circulation is not given. Okay, so for 1200 daily circulation, you can find if you have this beta, these two parameters you have calculated. Okay, if you trained your model and you find the optimal value of these two parameters. Okay, so you can now predict this Sunday circulation using what daily circulation for particular daily circulation, that is, let's say 1200, using this formula. Okay, using this model. This is basically your model. So what we will do, but how you are going to find out the value of this beta naught and beta 1, that is the main thing that we have to understand. Okay, so what we will do, we are going into little bit detail. Okay, so here you will go, and let's say this is your Sunday circulation. So and this is your Sunday circulation. The vertical line are the that you are going to say y-axis, and horizontal, that will be your daily circulation. Now you are going to plot a straight. You are going to plot a scatter plot. Okay, so this will look like something this. Okay, what we have, what we did, we are going to plot a straight line for this thing that will pass almost all of the data. Okay, most of the data. Okay, so these two different, let's say that I'm going to plot these two different lines. Okay, so what will be there, one line is, this one is another line and this one is different line. Okay, so one line we have this, one line we have this. Okay, so here you can find out, this line, basically this line is nothing but what, your model. Okay, and this you can use if you are going to represent this daily circulation using X and this Sunday circulation using Y. Okay, and you are going to say that the slope of this is, so you are going to represent this straight line as y equal beta naught plus beta 1 x. Okay, you are going to represent like this. So what you will do? What you will do? This basically is straight line. This is straight line. You can find the value, and for the sake of the simplicity that you go, this will not be exactly. See, if you are going to find out on the basis of x, the actual value is here. Actual value is here, and this will be your predicted value. If you are getting the point, so let me make with the different. Okay, so this value is what predicted by this straight line. Okay, so I'm going to say predicted value and this value as my actual value. Okay, so this will be actual value. Okay, so you are going to predict using this line. This is straight line. So to make a difference between the straight line, that is actually it will have, I'm going to say it as this y bar, y hat, that is expected value, like either expected value or you are going to say estimated. Okay, estimated value for the daily circulation when for the Sunday circulation when your daily circulation is given. Okay, so what you can find, you will find a straight line y, this one beta naught plus beta. Okay, and x is given. So this is your estimated, uh, that is what estimated Sunday circulation. Okay, and this is your x, that is, yeah. Now what you say, that you are saying that this is y, this is basically, this will be the actual value, and here this will be your predicted value, that is this y bar. Okay, y hat. Okay, so what you will say, this from here to here or here to here, you have some error. Okay, you will have some error. Here you will find this is your actual value and this is your predicted value by this line. Okay, so what you will say, this is error. There are error, some errors. Okay, so what you will do, to find out actual value, whatever you have predicted value, you will have some error. Okay, so this is your, this is your predicted value. You are going to add the error to get the actual value. Okay, so this error may be positive or negative. Sorry, this actual value is nothing but y, and your predicted value is nothing but, I am using y hat. Okay, to make some difference. Okay, so this will be your, now what you are going to find out, you are going to find out this error for a particular data point. This will be for a particular data point. This is for the particular predicted value or estimated value for a particular value. Okay, for a particular, let's say 405. So this is predicted value, and this is actual value. Okay, so what you will do, sorry, so you can find error actual minus predicted value like this. Okay, now what you have to do, you are going to find out, you are going to sum all the errors. Here the error, let's say that this one error 1, this is error 2, this is error 3. So from here, starting from, you are going to find error of all data points. Okay, let's say that how many, 100 data points we have, so we are going to add all the errors. Okay, so you are going to add these differences. Okay, this will be the case. Now you are going to here, same error you are going to find here, error, some errors are there. So for this thing, you are going to find out the predicted value as beta naught plus beta 1. Okay, x. And you find this will be your beta naught. Okay, and the slope of this, okay, slope will be your beta 1. Okay, and here also this will be the predicted, this one intercept, and for the slope you just go and find this value and this value and divide by this value, divide by this value. Okay, so you will get beta 1. So this you will get, this will be represented by this straight line. Okay, and now what you are going to do, now you are going to find out all the errors. You are going to sum all the errors and you are going to find same way. Okay, so in theory, you will have multiple straight line like this, but your model, your regression model will be that line that will have the minimum, this minimum error. Okay, you have to find out which straight line gives you the minimum error. Okay, so there are different techniques that how to calculate the minimum errors, but our main aim is to find out to minimize this error. Okay, if you are able to minimize this error, you are going to find out that straight line as your model, regression model, and that will be your best fit line. Okay, so in these two, if you are going to compare in these two, this straight line will be best fit in comparison to this straight line. Okay, so let's say that you find your best fit line. So what you did, you calculated beta naught and beta 1, this intercept and the slope. Okay, so these two things you find, and now using these two things you are going to calculate, you are going to predict for any new value. Let's say you are going to predict for this. Here you don't have any value. So for this you can predict. Okay. So if you have, you find, you calculated, you estimated beta naught and beta 1. So for any new value, let's say, let me clear all these things. Okay. So now let's say that this straight line is your best fit line. Okay. Best fit. Now I'm going to say this is as model. This your line will be the model. Okay, regression model. So for using this model or this line, you can predict for any value that is not in our data set. Okay, so let's say that here there is no. Okay, so you can find like this. Okay, and you will go and you can find. Okay, now this will be your predicted value. Okay, this will be whatever the predicted value by this straight line for this particular data means. How, what is the daily circulation? Let this is the daily circulation. Then what will be the Sunday circulation? That will be predicted by this your straight line. Okay, and now your straight line, that is you already know, you already calculated. How you calculated? By minimizing the error. And how you are going to minimize and how you are going to calculate? You are going to train your model or your algorithm. Okay, when you have trained, so there are different techniques to train. There are different techniques, and okay, when we'll implement, you will see that how training is working. Okay, let's move ahead. I think you got a lot of things about this. So finally, how you can find here. Okay, so your Sunday circulation will be this, and you will have, so this will be your actual. So let me just clarify this. Actual Sunday circulation, this will be actual daily circulation, and using these things you find a relationship. Okay, so this will be your actual value, that is the Sunday circulation, and this will be actual value for your daily circulation. Okay, so you are going to minimize this one, and using this formula, you can directly calculate. Okay, you can directly estimate these two, beta naught and beta 1. Okay, these are beta naught and beta 1, but just estimated. Okay, so you can write like this: beta naught this and beta 1 this. Okay, so these will be these cap values that we are writing here. These will be estimated values. Okay, these will be the estimated values. Don't confuse with this beta naught and beta 1. We are going to replace this beta naught with this beta naught cap and this beta 1 using beta 1 cap. Okay, because we are going to estimate, we are going to calculate, and always the calculate estimated values will have something that will be the errors. Okay, so after minimizing the error, we estimated that these values will represent the best fit line. Okay, so this will be the line, straight line. Okay, and this will be the model. Okay, and this will be your predicted value. This is your actual value for the this daily circulation. This will be y cap will be your predicted value for the Sunday circulation. Here, this is when you have error terms. When you have error terms, this always will be your actual value. Okay, like see here. If I go, you can find here that where it was. Okay, let's move these things. Okay, in this, okay, sorry. In this, like we have done here, just this value or this value will be your actual value and this value will be your predicted value. Okay, so if you want to find out the actual value, so you have to add or subtract from the predicted value this error. Okay, so actual value will always contain some error when you are going to when we are going to take with your predicted value. Okay, so let's move to this one. Okay, so let me remove all these things. Okay, so we've calculated this and finally I'm going to say Sunday predicted. This is Sunday predicted. Okay, and this one is my estimated intercept, and this is my slope or the gradient that is estimated, and this is my daily circulation. And daily circulation, yes, of course, daily circulation is your actual daily circulation. If you have any new daily circulation, so you can use that new daily circulation to predict Sunday circulation. That will be your predicted value, not actual value. Okay, so let's move to just quick that we can go quickly. We can go to these things. These are not just these are the important, but we don't have too much time to go into the detail. Okay, but just this is very important, so I'm taking this one. Okay, so what this is basically, this is R square. One way to find out this is basically accuracy. Okay, when you trained on the data set, you got that your regression line, something like that, and these things. Okay, you got your regression line, but what is the accuracy of your regression model? Okay, how much it's going to explain. So this, if you want to understand, you have X here and you have Y. Okay, so as much you are going to get this R square value. Okay, we will calculate, and these things, all these things, whatever I'm talking about here, I'm going to show you in detail using programming. Okay, in Python. So what is that? If your value, this R square value, you are getting 0, then means it says that this X value has no relation with this Y value. Okay, so if this X is increasing or decreasing, this is not going to change Y anyhow. Okay, so we are not going to make any relationship between X and Y. Okay, if your this R square value is 1, then it is 100% correlated, and you are going to, if there is 1 unit change in X, there is 1 unit change in Y. Okay, so this way you are going to find out if in between, let's say 0.8 you are getting. Okay, so this way, how much effect, what is the strength of your relation, this relation, how much effect this will make on your Y when there is some change in X. Okay, so how much this Y is going to change. Okay, so in other way we can say that how much this Y will be explained by the X. Okay, that is fine. So in that, if you know the variation, what is the variation, and how much variation is there in Y, how much variation in the X. So if you are getting one directly, this one value. Okay, so you are going to say whatever the variation in Y is, that is going to that you are going to explain by the X. Okay, so means everything you are going to, every data point in Y you are going to explain using X. Okay, so this is basically nothing but it will give you accuracy of your model. Okay, so if you are getting this value, R square value, as what, 0.8, so this means you are getting 80% of accuracy, means you are going to predict correctly 80% of your data points. Okay, so let's move to the, let me check that if you have any other thing to explain that are important. Okay, so these are the intercept and expressions. Okay, so let's go to the that one. Okay, so if you have any doubt up to this, let me know, and we are going to implement. Okay, so most of the theory that for the simple linear regression we have completed, and we are going to see, we are going to check that how we can implement simple linear regression. Okay, so this will be basically this thing. Again, I'm saying here, again, I'm going to share this repository link. Okay, so make sure that you have downloaded. So this is the repository that I'm going to put all the files day wise. Okay, so this is day 11. So I'm going to put here and put all the files here. I already have shared here all the files. Okay, so you can go and you can check. So first, at least these two files you just download: newspaper, this Jupyter notebook, and this newspaper data.csv. Okay, so because we are going to implement linear regression, that is simple linear regression, using this notebook. Okay, we'll use this notebook and this data set. Okay, so what you can do, if anyone is going for the let's say locally, okay, so they can go to any terminal command prompt or the PowerShell or any terminal you have, okay, and go to the where your data set you have, okay, your data set and your files you have, or where you are going to put your data and all these things. Okay, so go into that. So let's say that where I have, I think this is, okay, there's experience this thing, and within this I'm going to, okay, if I have, okay, let me check all the files I have in this. Okay, day 11. In that day 11 I have, so again I have to go into day 11. Okay, so now I am in this folder, day 11 supervised, and I have in this all the files, okay, cars and all these newspaper data, and this CSV file also. This CSV file, and where is my newspaper? This is my Jupyter notebook. Okay, now what I can do here, I can here, if it is okay visible, so you can find, I can just write Jupyter notebook. Okay, so in the first class, in the first session, I had shown that how you are going to install different libraries and how you are going to open this Jupyter notebook. So just enter Jupyter notebook. You have written Jupyter space notebook, so it will, what it will do, it will open localhost. Okay, localhost Jupyter notebook, you will get like this, and in browser basically. Okay, so here what the different things I have, and okay, that was basically not 11. Okay, but we can move to this, and we can go one back. How can we go? Okay, let me open CMD, another CMD, and let me go to XLR. Then for this, then day, basically what is that? Not 10 but day 11. Okay, because supervised learning, it is in this day 11, and earlier that we have done, that was day 10. So let me do this Jupyter notebook here, and I'm going to use that. Okay, so not this, but basically I'm going to use this one where I have my all the things. Okay, so if you want to go locally, you can go this way, and you will have this these files. Okay, all these things, and where you have downloaded. Okay, so go into that folder where you have downloaded all these things, and just open news underscore paper ipynb file. Okay, So already I have written all these things. Just I will go one by one and I will try to make understand. Okay, so that you will understand all these things, okay, properly. So this is one way that you are going. Another way, let me show that how we can go. Okay, so if anyone who is not using, like who has not installed all these libraries, okay, Python libraries, like what we need, you need Python first, you install, and Jupyter notebook. These two things are required to run these things that we are using. Other is that we are going to use different Python libraries like NumPy, Pandas, SciPy, okay, and different things. And today that we are going to train our model using scikit-learn. So you have to install scikit-learn also, sklearn basically. So this library you can find scikit-learn. Okay, so this is the library that we are going to use, scikit-learn. And this scikit-learn, how you are going to install? You are going to install scikit-learn pip install. If you check, okay. So always try to go to this pypi. Okay. So how you are going to install? Name is scikit-learn. Okay, and you are going to, how you are going to install this scikit-learn. But when you are going to import, you are going to import as sklearn. Okay, so there is little bit difference in this. Other libraries, like you are installing NumPy, let's say NumPy pip install NumPy, you are going to import NumPy. Okay, same name you are going to install, and same you are going to import. Okay, but here there is little bit difference. When you are going to install, you are going to write pip install scikit under hyphen learn. Okay, so you just copy. But when you are going to import, you are going to import as import sklearn. Okay, sklearn. Okay, so we'll see all these things. So make these things that you have already installed. Okay, if you are working locally. Okay, if you are using any other like a Google Colab or the Kaggle, also Kaggle notebook you can use. Okay, so you are going to, you need not to install locally anything. Okay, directly you can import. Okay, already you will get all the things installed virtually for you. Okay, so here what we can do, see what is the purpose of this one, that what I want to show, scikit-learn, you can find lot of the models already written. Okay, just you have to use that model and just to train the model on your data set. Okay, so what you will do, classification, regression, clustering, and dimensional reduction, model selection, different thing, pre-processing. For the pre-processing, as I think we have seen that you are, when we are transforming feature engineering, we did in the last session, that we have used these things. Okay, for the pre-processing. So model selections. Okay, there are different types of the models you can find. Almost all type of the supervised and unsupervised learning. Okay, so for the regression classification. Okay, so today we are going to do for the supervised learning, and in that we are going for the regression. Okay, so you can find there are different types of the linear models, and there are different types of the regression. You can find where it is your regression. Okay, so here different type of the regression, but what we are going to do, linear regression. Okay, so just you search linear, where it is, let me check, linear regression. Okay, okay, linear model. Okay, in that linear model, you will get basically ordinary. Okay, linear models, and okay, go here. Just go here. Okay, you will get different things. Okay, all the how linear models works. Okay, so you'll get the intuition, what, how you are going to minimize this data. Okay, how you are going to minimize, and you are going to get. Okay, so there are different ways. Ordinary least square is another method. Okay, regression. There are different. Okay, different models. Okay, so any of the models you can use for the for finding your relationship between your target variable and your input features. Okay, so today we are going to work on linear model, that is linear regression. Okay, so here it's I'm not able to find, but you can search linear regression model. Okay, linear regression scalar. So you'll get this model. And this linear regression model will give you the relationship between your output feature or the target variable and input features. Okay, and it will give you a straight line if it is only two variables. Okay, and if it is multiple variables, multiple input features, so you will get a hyperplane. Okay, so we are not going into the multiple features, we are not going into hyperplanes. Okay, just to understand these things, how you are going to fit in all these things. So let's start in detail that how we are going to work. Okay, so if you are working in Colab, okay, so what you'll do, just go for the Colab, just search Google Colab, and you'll get colab.research.google, okay. And if you have already done, okay, we already done this EDA last time and other things, okay. So you will get these things your first time, okay. So what you do, just go to upload, okay, and just go to browse, and whatever we have downloaded here, okay, from our repository, whatever you have downloaded and wherever you have downloaded. Okay, so go and find that Jupyter notebook, this Jupyter. Okay, so you can go for that one. Yeah, so newspaper. Okay, and for that thing, what you need, if you are working locally, and in that, let's say that in same folder I have my this Jupyter notebook, and in same place, same working directory, same location, I have my this data. Okay, so directly you can give, you don't need to put the your path. Okay, directly just give the name of this thing. But here I'm working in the Colab, so I have to provide the location, where is my data set. Okay, so this is virtually, we are doing virtually. Okay, we don't have access directly to my local machine. Okay, so what I will do, I will upload here my data set. So how you are going to upload your data set, you already have downloaded, so you can upload in sample data. You go and you can check, there are different by default there are different data sets, different CSV file already given by this Golab. Okay, so what you can do, just right click and you can go for the upload. Okay, so you just go and upload, and you go where you have downloaded. Okay, so this newspaper data we need to upload. Okay, now two things you have done, I've uploaded my data and I have uploaded my this Jupyter notebook. Okay, now this will not work because this is not the exact path where my data set is. Okay, so what I will do, I will copy my data. Just double click or right click basically and go for copy the path. Okay, and go and put here the complete path. Okay, so basically what is the working directory here in Jupyter when we are going to work in this Colab? Basically it is content. Okay, and within the content, all the things, sample data and other things, whatever the Jupyter notebook you have uploaded, all these things will be within content. Okay, and within content, this is sample data is there, and within sample data we have uploaded our newspaper data. Okay, so up to this I hope everyone is clear. So if you have any doubt up to this, please let me know. And now let's proceed. Okay. So what first thing we need? Okay. As earlier we have done, we are going to read our data as a pandas data frame. Okay. So for that thing, I want to import pandas. Okay, pandas library. We already have installed. If anyone has not installed locally, if anyone is working locally, so what he or she can do, directly he can go to the whatever the command. Okay, let's say terminal you are using, I'm using command prompt, you can use terminal. Okay, PowerShell or different terminal you can use. So just you can use pip install what, pandas. What is that? And to make sure that you can go pip install pandas. Okay, just check. Okay, so you can go with this library, this one, pypy.org. Okay, so you'll get exact this thing. Okay, as we have seen for the scikit-learn, you are going to install like pip install scikit hyphen learn. Okay, but we will see that how you are going to import this one. Okay, so what you will do, just copy and you can go and just put here. Okay, this pip install pandas, hit enter, and this will install the pandas. So for any library you can search here, you can search and you can copy and you can just install. Okay, so we have already installed all these things. If you are working locally, okay, we are going with Jupyter. Yeah, this one Colab. So you need not to install anything. Okay, you will be given all the things by Colab. Okay, by Google. So just run this one, pip this import pandas and PZ. So how you are going to, either you can click this one or you can just shift enter or the control enter. So any way you can go and you will find it there is this is connected. So if it's not connected, you will be it will take some seconds to connect. Okay, now click this one. So here pandas library give you function that read underscore CSV. This will read CSV file. You can not only CSV file, you can read this Excel file also, text file also. Okay, so you have to give here some parameter. So we have CSV file. By default, it will read CSV file. Okay, so we have CSV file here, all the data. So just check that how my data looks. Okay, so if you are checking for the just like first five, already we have seen all these things. So let me open in the Excel file and let's check that how your this file looks. Okay, so you have your data like this. See, so this is what newspaper, what is newspaper name. Okay, so let me do this one and this. Okay. Okay, so what is your daily circulation? This is these numbers. What is your Sunday circulation? These numbers. And what is the newspaper name? Okay, so we are not going to deal with these newspaper names because these are the some categories. Okay, some yeah, some categories or some the text values. So we are going to take only the daily and Sunday circulations because our regression model will work on the numeric values, and most of the machine learning models will take numeric values. So why I'm saying most, some machine learning models are there. Those can take categorical values also. Okay. So we are going to talk about these two. Okay. So we have Sunday circulation. That will be Sunday circulation will be what? Your target or the feature. Okay. Your daily circulation will be what? Your input feature. Okay. So what we are going to do, we are going to talk about these things. Okay, so you have daily circulation and Saturday circulation. Yes, if you have any doubt, so please put into the here chat. I will. Okay, yeah, so one more thing that if you have any doubt like this, so let me put again the let me put again the this one, that is basically what GitHub repository. Okay, so GitHub repository, I am passing here GitHub repository just for everyone. Just check and just go to the day 11. Okay, supervised learning regression, and download these two files. Okay, so newspaper notebook and newspaper data CSV. Yes sir, can revise all in short. Okay, so can we revise? Okay, at the end I will revise. Okay, at the end I will revise in short. Okay, yeah. So let me first do these things. So because we don't have much time. Okay, at the end I will revise. Okay, yeah. So where we are here. Okay, yeah. So you can find all the data frame, all the data points, whatever you have. So that directly you can print. If you have not too much data, you can directly go and just print all these things. Okay, so you can find out how many daily and all these things are there. Okay, so we already have done. Okay, these things. So let me go very fast because last day, because previous day we have done all the ED and other things. So we are not going to deal in detail. Okay, we have done regression, correlation also. Okay, so just yeah. So we are going to find out what we are going to take here from the data. I'm going to take only these two. Okay, only daily circulation, daily and Sunday. I'm going not to take this newspaper, okay, because these are the categories, name of the just name of the newspapers. Okay, so I'm going to take my data as daily and Sunday circulations, only these things. Okay, so for the head you can go and find. Okay, and if you want to find all the data, so you can go like this. Okay, okay, so what we have now, we have only daily and Sunday circulation. So this Sunday circulation will be your target, and this daily circulation will be your what? Your input feature. So we are going to feed a machine learning model, that is linear regression model, and we will find out what relationship between these two features will be. Okay, you can find the correlation. So there is very strong correlation. Okay, that it's a 0.95. So if any change, a little bit change in daily circulation is there, so it's going to make effect on the Sunday circulation. Okay, so correlation, we already discussed that if correlation is near to one, so very strong correlation is there, and if it is near to zero, so it's near to zero, so it's going, there will be no correlation between the variables. Okay, so this shows basically very strong correlation. Okay, so we can find if very strong correlation is there near to one, so we can go for the linear regression and we can find some relationship. Okay, so if you are going for whole, let's say that you are not taking only the numeric values, so you can put here a parameter that is true, numeric only, so it will give you this thing. So we're not going to do that one. So again, I'm saying that here you can plot. Just you can use plot dot scatter plot. So data frame will give you different plots to plot between different things. Okay. So one type of the plot is scatter plot, and you will use daily and Sunday. So this daily, here you can check, just run this one, and yeah, if it is visible and clearly visible, so you will find, so this is daily circulation and this is your Sunday circulation. Okay, so what is my main aim? My aim is to find out a straight line like this. Okay, so if you get a straight line like this, and for that straight line you will get exact values for the beta naught and beta 1, and here you will get daily. Okay, and here you will get Sunday. Okay, so Sunday circulation on the basis of daily circulation we already have discussed. Okay, so we are going to find out this straight line, and for that thing what we are going to do, we are going to basically create our model. This is creating our model. Okay, so for that thing I'm going to import, see here, when installing, this was scikit hyphen learn. Okay, it was scikit hyphen learn. So when you are going to install, so you will write like this, scikit learn. So it will be pip install. Okay, pip install scikit learn. Where you are importing, then you are importing sklearn. Okay, so make sure that you don't make any type of the error. Okay, so what it will be? Okay, if is it visible, let's make like this. Okay, yeah, so this is sklearn, and from the sklearn we have a linear model, and within that linear model we have a linear regression model. Okay, so you can go and you can check here, I think we have gone through somewhere. So linear regression sklearn, and I had shown you. Okay, so okay, let's say it will take time. So this model. Okay, so this is basically what you see, sklearn, linear model, and then you have linear regression. Okay, so this is a class. Okay, from here to here, so linear regression is a class, and I'm going to use that class to do these things. Okay, so you will have X and you have Y. Okay, so generally you are going to represent your input feature with capital X and the target value as small y. Okay, so you just take from the data frame, you are going to take daily as your input feature, and you are going to take your Sunday circulation as your output feature. Okay, so you just run, you can find out what is my a daily circulation is something like that, and you can find out your Sunday circulation. So what we did, we separated the target feature and our input feature. Okay, now this is what we have already imported. See here, we have imported my this one linear regression from sklearn dot linear model. Okay, so sklearn is your library. This linear model is a module. Within that, the package a module. Okay, module, and within this module, this linear regression class is defined. Okay, so make sure that you are clear with the package, module, and the library and all these things. Okay, so this linear regression is basically a class, and we have created an object of this class that is my model. Okay, so let's run this one. So sorry. This is not. We haven't run this one. See, you can find here we haven't run this one. Okay, so you just run, and what is that? Okay, attendance video. So you run this one and you will get, okay, so we have created model. So now our model is created. This is nothing but this is an object in Python. Okay, object of class what, linear regression class. Okay, so we have linear regression class, we have defined a model that is an object, and now this object we are going to fit using my input feature and my output features. Okay, so I'm going to use these two things. Okay, so this y is basically what we have taken into Sunday circulation into y. See here, Sunday circulation we have stored in y variable, and daily circulation we have stored in my x variable. Okay, so this is generally, this is the convention, that for the input feature we are going to take capital X, and for the output or the label or the target we are going to take as lowercase y. Okay, so what, just you pass these values, okay, x and y, so it will take all the values of Sunday circulation and all the values of the daily circulations. Okay, so daily circulation and Sunday circulation, and it will fit the model. Okay, now when I said that fit the model, what it does basically, what it does when I'm talking about, when I'm talking about when it fit. Okay, so we have our data point like this. Okay, this will find this fit function, this fit method will try to find out this straight line, and this beta naught and beta 1 means intercept. It will try to find out intercept. Okay, and the what is that, gradient or the slope. Okay, it will try to find out these two, such that whatever we talked about the errors, so error was, there were some errors, there is error, this error. So these errors will be the optimal one or the minimum one. Okay, so it will find this line such that all the errors, means some of the errors or the some of the square of the errors. Okay, so will be minimized. Okay, when we train, it find the best way, best fit line. Okay, and that best fit line will give you the minimum error, like this one. We have done all this. Okay, for all you calculate, all you takes the errors. Okay, and that it will take into account this fit. Okay, so now we got, okay, we got model. Model is nothing but my straight line. Okay, so we got a straight line. Now you can check what is the intercept. So what is the intercept here? 13 point this. Okay, so you can go and let's say, okay, So this intercept here is 13. This value basically from here to here is nothing but what? So let me draw a proper. Okay. So you get a straight line like this, and this value from here to here, from here to here is your intercept, that is beta naught. Okay, this will represent the value 13 point something we got. Okay, so this 13.8 or something that we got, that is your value of beta naught. And this slope, what will be the slope? That slope is beta 1. And what the slope value is, so you can find slope as a coefficient. Okay, so whatever, let's say that this type of the beta naught and beta 1 x is there, so this will be your whatever you have done, and this value, to find out this gradient you can use coefficient, because this is the coefficient of x. Okay, so in mathematics way, if we go mathematical way, so this beta naught is nothing but coefficient of x. Okay, so that's why we are going to talk about the coefficient. Okay, but make sure that if you have not only a single feature, single input feature, you can get like this: beta 1 x1, beta 2 x2, and the different things. Okay, so you may get different coefficients. Okay, beta 1, beta 2, and these things. So all these things you can find as coefficient. Okay, and this will be your intercept. So when you got the model, okay, so model dot intercept you say, and model dot coefficient you say. Okay, so you will get the coefficient if only one coefficient is there, so you will get one value. If you have different coefficient like input features, you have multiple input features, so you will get different coefficient. Okay, these are the different things. So now to get your this value. Okay, so we got beta naught, beta 1 how much? 1.34. 1.34. So you get this one, and beta naught you will get 13.8. Okay, so now what you will do? This way you can just, you can find Sunday circulation as what? Beta naught is 13.8 something plus 1 point, beta 1 is what? 1.34 something, and daily circulation. Okay, so for any unknown, for any new daily circulation data, you put here, let's say 1200. Okay, and you just multiply with 34 and just 13.8, you will get Sunday circulation. Okay, so this line, this is straight line, this is nothing but your model. Okay, this is your model, and using this model you are going to predict for the Sunday, you are going to predict Sunday circulation for any daily circulation. Okay, I hope this is clear for all. So we have calculated what Sunday as, what is the model intercept? Intercept is nothing but your beta naught. Okay, and model dot coefficient, that is your what? That is nothing but your gradient. Okay. Okay. So let me go with these things, that what is actually, that this was the actual value of your. So let me show that whether we have run all these things. Okay, we have run all these cells. So you'll get this is your actual y. Okay, and how you are going to predict for this. So this will be y model dot predict. Okay, this is the function name that you can use. Okay, so you can go and read these things. Okay, there are a lot of the functions and these things it will have. So this model dot fit is nothing but to train. Okay, and model dot predict, to predict for the new value. Okay, model dot score, to find out the accuracy of this score. It will give you R score that we have discussed. Okay, and one more thing is there, that you can find out model fit, model dot parameter you can find, and these things. Okay, we'll look into these things. So just to predict x is what? You can find out your x, that is your daily circulation. Okay, so before that, if you want to find out, you can print capital X. Okay, so this is your daily circulation, and this is your Sunday circulation. This is your actual data. Okay, now you can predict Now you can predict your Sunday circulation on the basis of this daily circulation that is given. Okay, and you can find out what are the predicted value for actual Sunday actual daily circulations. Okay, so first data you will take 538, and you find here y is nothing but 488. Okay, so this is your actual. So let me show that my actual value is 488. My predicted value of Sunday circulation is what? You can find here on the 538. 538. So this is predicted using my model. Okay, so you'll find here there is some error. Okay, that is the error that we were talking about, that how it is going to train. Okay, so you can take any value, 706 predicted value, and here your 798. Okay, so it is that y is 798 and y predicted is what? You can find out the difference between these two. Okay, 706. 706. So the difference is basically error. Okay, that we were talking about these things. Okay, so using any regression model, you are not going to find out exact values. Maybe in some cases, you will get the exact values. Okay, but most of the time some error you will get. Okay, so what can you do? But this model, whatever we have found, okay, this is the best model if you are going to take any other values for these naught and beta 1. Okay, for these values, so it will give you more errors. Okay, so this is the thing that you have to go into, that you have to interpret these things. Okay, so you can go for these things. This is basically actual. And okay, so what you can do, we are going to plot our model using this one, matplotlib. Okay, so this matplotlib library you have to install if you are working locally, and if you are not working locally, you are working in Colab, so that's good. You can use directly, you can import matplotlib .py.splt. You can go for the scatter plot or this, or you can directly go with your one that thing, data frame. Okay, data frame also give. Okay, yeah, we are using data frame here to plot. Okay, and to put this red line, we are going to plot a straight line. Okay, so you'll find here like this. So this line is nothing but this line is representing your model. Okay, and how this model is presenting this Sunday circulation, that you are going to say is Sunday circulation predicted value, that I am going to say as a this cap. Okay, how much you have to find out what was the beta naught. Okay, so what was the beta naught? So let me check that what was the beta naught. Where is it? Where is it? Where is it? Okay. So this is the intercept, the 13.8 and 1 point, let's say 4. Okay. So let me write here, and beta naught is 13.8 plus 1.34. You are going to use this thing. So I will make little bit more clear. So let's understand first. Let's go here and try to find out like this. This is my model. Okay, we already have done this one, and let me annotate properly. So this will be Sunday circulation that is predicted. Okay, so I'm going to make difference between this Sunday circulation, this is the exact values, and this Sunday circulation as the predicted by this straight line as 13.8 plus 1.34 into what? Daily circulation. Okay, so if you have any daily circulation value here, if you have any daily circulation value here, uh, like this. Okay, let's say 1000 or something like here you can find. Okay, here you can find in between 700, around 700 we don't have data. Okay, so for that thing you can predict. Okay, so for that thing you can basically predict. So you can find out this and you can predict. Here you can put the daily circulation for 700. You just multiply 134 and just add 13.8. You will get Sunday circulation. Using this one, that will be your predicted value. Okay. So this is nothing but your model. Okay. So if you have any doubt, please let me know. And okay, so one doubt we have, what are the limitations of this regression? Okay, so there are many limitations. There are, okay, so if you're going into this, a single simple linear regression that will take only daily circulation. That is basically, please give me okay, sorry for the disturbance. So what is that? Up to this, what we did, we found that this is basically, yeah. So we did all the things, almost all the things. But one query that I have, okay, that is basically what is the limitations, okay, of this regression, whatever we have done, okay. So there are lot of the limitations that you can check here. That let me write here, that one is that it is taking only single input feature. Okay, only single input feature. Okay, if you have multiple input feature in your data set, so you have to go with multiple linear regression. Okay, that is the one thing. Second is that then there may be a case of the like overfitting. Okay, maybe a case of overfitting. So what does overfitting means? If my this state line is going to learn all the data points, okay, so it will give you very good accuracy. We'll see that what will be the accuracy at the training time. Very good accuracy at the training time. So good accuracy at training, okay, but not good accuracy, or not it will not regularize on the testing. Okay, it will not. So when you are going to predict new data, for the new data, it will not give the proper result. Okay, so maybe this case that this will not be used. So what can we do to regularize, to avoid overfitting? We can use different regularization techniques. Okay, so like this regression is there. Okay, lasso regression is there. Okay, so all these are again the regression techniques. Okay, so you can find there are different. These are very simple. This is the very simple, and my data set is also very simple. Okay, that it gives you this is straight line. Okay, and this straight line is generally what good straight line, and this is best fit. Okay, but in not every time you will get this type of the data. Okay, so what you have to do, you will not get always that only one input feature is there. You may get your 10 input features, may more than that. Okay, you may have like hundreds of the input features. So if you have multiple input features, most of the time the problem you can get overfitting. Okay, so to reduce the overfitting, you can use any type of the regularization techniques. Okay, and there are different things that in pre-processing that you have done. Okay, you can do for pre-processing, and we will learn how we are going to basically we are going to divide our data set into whatever the things are there, like training data set and testing data set, training data set and test data set, and validation data set. Okay, so we can use validation techniques also to improve our accuracy and to avoid the overfitting. Okay, so there are different techniques we will use. Okay, obviously, and definitely we are going to use, okay, in I think the day after tomorrow. Okay, so you will find day after tomorrow there will be different techniques for the hyperparameter and how you are going to improve your accuracy. So when we are talking about you are going to improve your accuracy or you are going to improve your model, most of the time you are going to deal with overfitting and you are going to check all these things. Okay, so let's move to the find. Yeah, so you can find the accuracy. Okay, this is nothing but r score. Okay, r square, this coefficient of determination of prediction. So we already have gone through that this value is in between 0 and 1. Okay, so as it is near to 1, it will be the accuracy. Okay, so it's near to 1 like 0.91. So our model accuracy is what, 91.8%. Okay, so there are different techniques, like you can find mean absolute error, you can find mean squared error, and you can find square root mean square root mean squared error to find out the accuracies. Okay, and you check that what different things are there. Okay, so this will give you little more information about these things. And finally, if you go for the R2 score, R2 underscore score. Okay, so you'll get again same thing that here whatever we have done, like model dot score. This model dot score will give you directly the same thing. Okay, so from the scalar matrix you can find different classification, different regression matrices. Okay, so to evaluate your model. Okay, so you'll find for the this scalar dot matrix you can import R2 underscore score. Okay, so this is same way that you can find model dot score if model is your regression model. Okay, so our model is what, 91.8% accurate. Okay, so let's predict for the new value. Okay, so let's if we are going to predict for the 200 and 300 daily sales, so what it will be, we are going to convert. Basically we created a series and now we are going to convert into pandas data frame. Okay, because you see that our x data, our the input feature is basically a frame. Okay, and my y, my daily Sunday circulation, my target. Generally, whatever the things are there, whatever the target value or whatever the labels. Okay, target we are taking as a series one dimensional. Okay, and input features, maybe one input feature, maybe multiple input features. So we are going to take those as two-dimensional. Okay, so that will be your pandas data frame. Pandas data frame is two-dimensional, a tabular type things, and series will be your one-dimensional data. So yeah, so you can use model that predict for these two new data, these two new daily circulation for 200 and 300. You can take for 700, you can take for the 1200, and you can check. Okay, so just run these things. So respective way, if your daily circulation is 200, your Sunday circulation will be like 281, and if your daily circulation is 300, your Sunday circulation will be 415. Okay, so this is just the prediction. Your actual value may be different. Okay, so if you don't have 200 for the daily circulation in your data set, okay, so you can use these this model. You can use the model whatever we have trained on our data set to predict for the new data. Okay, these are the new data. These data are not available in our data set. You can predict for the new data and you can check that how much you can expect for the Sunday circulation. Okay, this is just for the exercise. You can go for this. I have already uploaded this CSV, and you can go for, and you can find that is there any relationship between the waist and waist circumference. It will give you the waist circumference and your adipose tissue data. Okay, so you can go for the this uh, you can find your model and you can predict for the new data. Okay, so all the things whatever we have done up to here, sorry, you can do for the waste circulation and adipose data. So you can find here that I have already uploaded this data. Okay, so waste wc underscore 80, you can use this CSV file and you can do the exercise. Okay, so if you have any doubt, please let me know. And one request that I got from okay, Rohit. Okay, so he asked for the revision in short. Okay, so let me just revise that what we have covered today. Okay, just let me revise. And meanwhile, if you have any doubt, so please let me know. I will try to explain and I will try to make it clear. Okay, so what we did today, we try to understand what is supervised learning. Okay, supervised learning. So when your data set is something like that, you have your target or the output. Okay, if you have target or output values, okay, you have target or output, you have data set, and what will be the target? You have data set, what class this belongs. This belongs for a diabetic class, this belongs for the not diabetic class. Okay, so this type of your data you will have, and you will have different okay input. Okay, so you have input, you have output. You have output or the target or the labels. So you are going for the supervised type learning. Okay. So any doubt? Anyone? Okay. Now it is done. So what you will do? You are going to perform a supervised learning. Okay. Now there is two different types of supervised learning that you are going to perform. One is regression and other is classification. Okay, so this will depend on the output values, which type of output you have. Okay, if your output of the target values are output values are continuous continuous data. Okay, continuous numerical data. Okay, obviously any data which is continuous, that is numerical. Okay, so you are going to perform classification. If you have like a discrete, or you have categorical like cat, dog, diabetic, not diabetic. Okay, 0 1 2 3. Okay, which class is belong? Zero class, class 2, class 3, class 4. Okay, so you are going to perform classification. So tomorrow we will talk about the classification in detail. So today we have done the regression. Okay, so if you have your data set, okay, if you have your data, that is your output. Okay, and if you have your input. Okay, so in the input you may have many values, like not only single value, but today we have done for the single value. Okay, you have one single column for the input and single column for the output. Okay, so when we are going for the machine learning, so we're not going to say that okay, this is input, this is output. We are just talking about that this will be output, will be our target. Okay, target are the labels. Okay, and my input will be our input feature. These are the features. Okay, both are the feature. Which type of the feature? Input feature. Which of the feature? Target. Okay, input features, these are the features. Okay, so on the basis of the values, this is continuous that we have taken. These are the continuous Sunday circulation, daily circulation and Sunday circulation. The we have taken height and the weight. Okay, or we have taken the experience and the salary. Okay, all these type of the examples you will do a linear regression. Okay, so what is basically linear regression? Okay, this is nothing but, don't go into the confusion, just we are trying to find out the relationship between these two variables. Okay, so when we are talking about this is output. So this output depends, this is your cell, this is output data, this is your input. Okay, so output depends on input. Okay, so output feature or output variable will depend on the input feature and input variable. So that's why this, whatever the output is, output values are dependent on this. So output, this will be the dependent variable, and this will be the independent variable. Okay. So now we are going to find out a relation. We are going to find out a relation between, okay, what is that? This is dependent variable, and independent variable are the variables. Okay. So how you can find this is basically generally we are trying to find the dependent variable as y and this as x. Okay. So if you can find any relation between these two, you can use that relation to predict for the new values. Okay. So generally that our linear regression or the linear regression model with be represented using a straight line, and that is straight line mathematically you can say y equal mx plus c. Okay, this is your slope, this is your intercept, or this is the coefficient. Okay, mathematically you can say this is coefficient and this is your intercept. Okay, and when you are going into the actual, okay, so we are going to say this as this, and we are going to take these two. These two will be treated as parameter, and these parameters is what? Nothing but what? These parameters we are going to estimate the parameter values. How? While training, we are going to train this model on the data set, and I'm going to find out the estimated value of beta naught and beta 1. Okay, so estimated value of the beta naught and beta 1 will be what? These things. So wherever the cap you are getting, okay, so that cap will give you the estimated value or the predicted value. For this will be predicted value, and for this beta naught and beta 1, this will be your estimated value. Why I'm talking about estimated value? That estimated value is a statistical or mathematical term, and when I'm going to say the estimated, it will contain some error. Okay, so it is not exact. So it is done using the samples, and we are not going to do all these things. Okay, on the data set. So whatever the data set you have, we have 35 data points. So on the basis of those 35 data points, you have calculated this. But there may be lot of the data points that you have not taken into account. So because of that, we may get some error. Okay. So that's why we are going to estimate this. We are not going to calculate, or we are not going to find out the exact value. Okay. So when you done this one, you found this one, now you can use this model, this particular model. Okay, the estimated value, and this estimated value and x to predict your whatever the y is, to predict your Sunday, and to predict using your daily circulation. Okay, so we have gone through this proper calculations and proper all the things that how you can interpret and all these things. And here you find that after fitting the model, you get the intercept, and basically you get intercept means your beta naught, that this a is there. Okay, and here the coefficient, you get the coefficient, that is nothing but whatever the model dot coefficient, that is your beta 1, that is your basically slope or the gradient. Okay, so you get all these things, and using these things, this was your gradient or slope or the coefficient, this was your intercept, and you calculated, you estimated using fit model. Okay, so you find these things, and now my actual aim was what? My actual aim was to find out these two. Okay, when I'm going to train the model, that we are going to find out these two beta naught, these parameters. Okay, so basically we are trying to find the optimal value of the parameters. Okay, when we are training the machine learning model. Okay, when we're training machine learning model on the data set, we are trying to find out the parameter values. Okay, so there are different machine learning models, and that inside there are different techniques that how machine learning model training works. Okay, how it is going, and in the linear regression, he's tried to find out to minimize the error. Okay, so he's tried to find out the minimize error in between this predicted value and the actual value. Okay, So hope up to this you got some insight, and Rohit, I hope that in short we have revised all these things. Okay. So if we don't have any doubt, so we can conclude the session today here. If you have any doubt, so we can take just 1 2 minutes. Okay, no issue. And if not, so we are going to conclude the session. So I hope that from the student side, there is no doubt. Okay. So Sushmita ma'am, we can conclude the session here today,
Yeah,
and
sure, sir.
please let me know that what will be the Zoom link for the tomorrow session.
I think the same Zoom link, sir. I will update you. The same Zoom link, sir, which you
Okay,
have used today. Yeah.
today. So how I get the today's link, that it was shared in the chat now. So if it will be okay,
Yeah, the
okay,
same
I will.
link will work.
No, no. For the today's link that we got in the previous one, that we have already that previous one link. Okay, so now we lost that link.
Okay, I'll just check and update you, sir. By tomorrow, I will update you.
Okay, okay, okay.
Okay.
Thank you. Okay,
Yeah,
that's
sure.
great.
Thank you, sir. Thank you so much. We'll meet again by tomorrow at 7 p.m.
Okay, thank you. Yeah, that's right.
Yeah, so dear students, kindly mark your attendance without any fail. So yeah, so the link for tomorrow's session, the link will be updated in LMS. The same link you can use it. The whichever link you have joined today, the same link you can join. The new link. Okay. Yeah. Thank you all. We'll wind up for the day. Thank you all. Good night. Thank you for joining.